All right, so yesterday we spent our time talking about sort of ecosystems in general, talking about some different categorizations within an ecosystem, community, habitat, population, and so forth. And we went into a little bit about energy flow. Talked about food chains and how energy comes into an ecosystem and moves through the ecosystem. So we only talked about food chains. Today we'll talk a little bit about what we call a food web. They're obviously very similar, but how are they different from each other? Like what's the difference between a food web and a food chain? Okay.
A web usually covers like more animals, and like shows the relationship between several primary and secondary organisms.
Yeah, so there's usually more organisms in a food web, and it shows more interrelationships. Imagine like if you have a chain is just one link to another, to another, to another, versus a web, which is what? Yeah, it's spread out, is interconnected. So a food web shows connections between various food chains. Okay, that's one way we can put that. And so food webs are more complex, and they're also more realistic. Okay, in an actual ecosystem, for most organisms, it's not just one organism eats another. Most organisms have multiple food sources, would eat multiple organisms to obtain energy. So a food web with more complicated relationships is more accurate. So a food web shows all of the feeding relationships within an ecosystem. It's basically several food chains kind of connected together, interweaved with each other. If you look at this is just a simple food web. Okay? But again, it's not a food chain because there's, the rabbit eats the wildflowers, it also eats the grass, the snake eats the mouse and the rabbit. So there's interconnection between multiple organisms. We can look at this food web and identify specific food chains. You could say, okay, one food chain from this food web is wildflower, mouse, hawk. Another would be grass, rabbit, snake, hawk. So we can pick out of that food web several different food chains. Now, if we imagine here for a minute, if you imagine an ecosystem that has all of these species, grass, wildflowers, mice, rabbits, snakes, hawks. If you were to gather up from that ecosystem all of the grass, and you were able to gather up in a separate pile all of the mice in that ecosystem, and in a separate pile all of the snakes, and separately all of the hawks, which pile would be the biggest?
The producers.
What do you think? Think there would be more mice than grass?
No, the producers.
The producers. What would probably be the next largest pile?
The mice.
Probably the mice. What would be the next largest pile? Well, yeah, the rabbit, if that's you're including that. What would be the smallest pile?
The hawk.
The hawk. In an ecosystem, you might just have one hawk. So that pattern that you just described to me is true of all ecosystems. And we use a pyramid to kind of illustrate this. Okay? The energy pyramid shows how large the populations are of various species in our ecosystem. And so we can sometimes think of it as numbers, like the number of grasslands versus the number of rabbits versus number of snakes. A better way to really think about it is in terms of energy, which contains the most energy. And the reason that the number of calories available gets smaller as we move up our food chain is because every time one organism eats another, it's not able to then use all of that energy to grow larger. Actually, 90% of the energy is lost every time one organism eats another. So if you imagine in this energy pyramid at the bottom, we start with on the bottom grass, the producers. And in our example, we have this made up example, we have 1,000 calories. That's the amount of energy contained in all of those grass plants. When grasshoppers eat that grass, they don't gain 1,000 calories of energy because lots of that energy goes into keeping the organisms alive. They use up energy as they're moving around. Only about 10% can go into actually growing the grasshopper population. And so then you have less energy available for the grasshoppers. When you have, these look like moles. Moles eating those grasshoppers, again, they eat all those grasshoppers, lots of the energy is lost, it's used up. And only about 10% goes into growing the mole population. When the owl eats the moles, again, 90% is lost, only 10% makes it to the next level. So every step up the food chain you go, you have less and less and less energy available, and therefore fewer and fewer of those organisms. It's because energy is used to keep an organism alive, to generate body heat, etc. Only 10% can make it to the next level. And this should kind of make sense because if you imagine, if you think about you walking around in the woods, going on a hike, what's the most you see, the most abundant organism? Plants, trees, and whatever, grass. What would be the top carnivore? The top of the food chain in like a forest around here?
Bear.
Bears are omnivores. Maybe a fox, let's say a coyote.
I've seen like out on like where the track is.
Mountain lion. Okay.
We
We don't see a lot of them around here. They are in our area. They're pretty secluded. But how many mountain lions do you see?
No, I've never seen one.
Right, probably none of you have ever seen a mountain lion. Why? There's not very many of them. If you imagine like hawks, they're the top bird predator probably. Do you ever see like flocks of hawk flying around? No, you see one or you see two.
I saw two of
Okay?
them.
You don't see large numbers of them. Okay? So those top carnivores, there's not that many of them because they are way at the top of the food chain. By the time energy gets them, it's gone through 3 or 4 or 5 levels, and there's not enough energy to support a huge flock of hawks in a small ecosystem. They need a large ecosystem to provide the energy to the top levels.
Well, aren't like we at the top, but like we have like a lot of people?
Yeah, humans are sort of an exception. We are, but we can also eat wherever we want on the food chain. For example, I choose to be where on this level? I'm a primary consumer, right? I don't need any animals. And so actually, I'm relatively low. And if you were to imagine the population of the Earth, the majority of people get most of their energy from where? Plants. Okay? From plants. Now, in a very wealthy nation, maybe, a higher percentage of calories comes from meat. But in most of the world, people don't eat big quantities of meat. And most of their diet is based in plants, with some additional protein from fish and other things. So generally, humans eat relatively low on the food chain.
So like, so what about like cold-blooded animals because they like use less energy?
Yeah, they do use less energy, but they still need to use a significant amount to stay alive. Same is true in the ocean ecosystem. Again, you could trace back, the sun shines lots of energy on the oceans. Little tiny plankton and stuff absorb that energy in photosynthesis. Gets eaten by tiny little animals. which gets eaten by very small fish, which gets eaten by larger fish and so forth. But again, every step we go up the food chain, we get less and less energy available. Again, you don't see a school of great white sharks swimming through the ocean, right? They're very rare. Okay? There's not enough energy to support huge numbers of those top predators. Again, same sort of idea. We always in our food energy pyramids have the most energy in the producers, and then as we move up the levels of consumers, we get fewer and fewer, less and less. Again, so same idea there. So you got the idea? All right. Yeah, don't worry about the questions. If you understand, there's a bunch of practice on food webs in here that we'll probably just skip over because I think you guys understand this well enough. Okay, another food web. We're going to do some practice as homework today. All right. So I think we could probably. You guys feel like you understand this pretty well?
Yeah.
We don't need to beat it to death. Oh, not there. Okay.